Welcome back to my channel Choose Aspirations. So today we are going to see the Euclid's division algorithm. So if you have not seen my previous videos, please go to the description, click the link and watch those videos, the basics of the Euclid's division lemma, and come back to this video and we'll have a great journey of this concept. And the people who are new to my channel, hi, this is Chiranjeevi, maths trainer and a motivational speaker. We have seen in the previous videos about Euclid's division lemma, that is A is equal to BQ plus R, where R is between 0 and B. And we also saw some of the problems how to solve it. And in today's video we are going to continue the concept of learning Euclid's division algorithm. So Euclid, the great mathematician, have come up with many methods. So here we are focusing of using a Euclid's method to find HCF, that is highest common factor. So let's see what is this highest common factor. So HCF is nothing but the highest common factor of two numbers. If you consider any two numbers like 48 and 34, let me say, so we are going to find the highest common factor for these two numbers. Before that, let me come to what is factors. Factors are the one or two numbers when multiplied gives a particular number. For example, 6 can be written as 2 into 3, isn't it? 2 and 3 are the factors of 6, whereas 6, 12, 18 are the multiples of 6. So the multiples are nothing but the repetitive addition of a particular number. So here we have taken 6, 12, 18, 6, again the 6 is added to 6, it becomes 12, again 6 is added to 12, that is 18. These are the multiples of 6, whereas 2 and 3 are the factors of 6. I hope you got the clarity between factors and multiples. Two or more numbers when multiplied gives a particular number are the factors, and the same number where the repetitive addition happens, those numbers are called as multiples. Now here the HCF for a particular 48 and 34, there are various factors for 48 and 34. We are going to find the common factor, that is the highest common factor for these two numbers. The Euclid came up with this method. So lots and lots of methods we have. Generally the idea behind this HCF is simple. See, if we take, for example, I have taken this 48 and 34. I am going to simply subtract. The repetitive subtraction results the highest common factor. Let me separate these two numbers, 48 minus 34. So 48 minus 34 is, now 48 minus 34 is 14. Just I need to find the HCF for these two numbers. I am just subtracting it. Now avoid this 48 and observe 34 and 14, which is greater? We have 34 as the greater number. Again 34 minus 14 is equal to 20. Now I subtracted 48 minus 34, 14. Again I am taking this 34 and this 14 subtracting, I got 20. Again I will omit this and observe this. Here these two numbers, among these two numbers, I have 20 as the greater number. Again I will be taking 20 minus this 14. So 20 minus 14 is 6, right? Again I will be considering these two numbers. Again 14 is greater. 14 minus this 6 is, again you will be getting 8. So again I will be considering these two numbers. 8 and 6, 8 is greater. 8 minus 6 is 2. Again I will be considering these two numbers. So 6 minus 2 is 4. Again I will be considering these two numbers. 4 minus 2 is 2. So whenever we got numbers same, so at this point of time, then that will be the HCF. Did you follow? So when we come any two numbers, we'll start subtracting. From the greater number, the lesser number will be subtracting, we'll be getting some number. So these two numbers, again avoid the greater number, again take these two numbers and again subtract it. From the greater number, the lesser number, you will be getting some number. Again avoid the greater number, again take these two numbers, which is greater, you take that and subtract. Continuously if we go, so at one point of time, this place and this place will become equal. And further, if we go to this, it becomes 2 minus 2 is equal to 0. So up to this point, if you continuously do, then this is nothing but HCF. This was the idea initially. I hope you have followed this concept. So generally, in simple words speaking, HCF is nothing but the highest number, the common number between two numbers, which divides the individual number exactly without giving any remainder, that is, the remainder will be 0. Let's explore this practically by doing an activity. Now we are going to find the HCF of 28 and 18. So for these two numbers, we are going to find the HCF. So I am going to take one side as 18 centimeter. First I will take 28 centimeter. And other side I will be taking 18 centimeter. So this side is 18, sorry, this is 28 and this is 8. Now one side I have taken 28 centimeter and other side 18. The target is we are going to find the HCF between 18 and 28. The condition is I need to draw a biggest square. So what I am going to do, so this is a rectangle of a 28 centimeter and 18 centimeter. So I need to draw a biggest square. What is the possibility of a biggest square? I cannot take 28 because a square has all the sides equal. I can take 18 centimeter and I can draw it here. See, this side is 18 and if I take this side also 18, so it becomes somewhere like this. It comes here somewhere. If I take that exactly, okay. Now I have drawn a square. This side is also 18 and this side is also 18. Now only one square I am able to draw here. The entire rectangle of a length 28 and the width 18 centimeter. So the condition is I am going to draw the maximum possible square here. So the maximum possible square here is the width I am going to take as 18 and I draw the square. Now the remaining is, what is 28 minus 18? It is 10, right? So this is 10 centimeter. This is 10 centimeter. And here again I got a small rectangle, like 18 centimeter is the length and the 10 centimeter is the width. So again the condition is I need to draw the maximum square here. So what I am going to do, so this is 10, I am going to forget about this square. Now I am going to consider this rectangle of 18 and 10 and I need to draw the maximum square. So maximum square here I can draw is 10 centimeter I can take. So again this side I am going to consider 10 centimeter and draw it. Now initially it was a rectangle. The possibility of drawing a maximum square I draw taking 18 centimeter and now here it is 10 centimeter. One side is 18 and the other side is 10. Again here the possibility of drawing a bigger square is 10 centimeter. I have taken 10 and this is all of dimension 10. Now the remaining is here. So if this is 18 and 10 gone, this will be 8 centimeter. And this is 8 and this is 10. Again this became a rectangle. Now I need to draw the maximum square here. So I will be taking 8 centimeter and I will be taking measuring here. Now this is 8 centimeter, this is 8 centimeter, and this is also 8 centimeter, and this becomes 2 here now. 10 minus 2, and again 8. Now I am going to consider this as small. This area I am going to focus now. From the entire width of the rectangle, now this became a rectangle. One is 8, another is 2. Now the concept is, what is the maximum possible square I can draw? I can draw 2. 4 squares can I draw here? I can draw 4 squares, right? Because it is 8. So what I am going to do, I am going to take measurements like 2, 2, 2 and 2. So I am going to take and draw it now like, yes. So everything is of measurement. Therefore, the HCF of this particular 28 and 18 is 2. Now, how was the activity? It was, we found the HCF of 28 and 18. The HCF of 28 and 18 was 2 through the activity. If we subtract 28 minus 18, we will be getting 10. Again, among these numbers, I am going to take 18 minus 10, again 8. Again 10 minus 8, it is 2. Again 8 minus 2, it is 6. Again 6 minus 2, it is 4. I am going to consider these two numbers, which is greater, I am going to subtract from that. So again 4 minus 2 is 2. Whenever I get same number here, then that will be the HCF, as we saw in the activity. The overall concept of the activity was, a greater rectangle we are going to break into multiple squares. Finally we will get a single square which divides this number as well as this number. So that was the concept behind this. Now we are going to see the actual Euclid's method. So this multiple subtraction becomes hectic when you go for the larger numbers. So Euclid came with a method called Euclid's division algorithm. We'll study that. Now for the same number I am going to consider, that is 28 and 18. So this is about Euclid's division algorithm. So what we are going to do, just dividing the common division. So here I am going to take 28 as the dividend, because this is the greater number, and I am going to divide 18 here as a divisor. So 18 ones are 18. Again I will be getting 10 here, isn't it? So this is the actual division. This is the dividend, the divisor, quotient and the remainder. Now Euclid's division algorithm tells that, we already know that Euclid's division lemma states that A is equal to BQ plus R, where R is between 0 and B, isn't it? So this condition here, A is nothing but the dividend, B is divisor, Q is quotient and R is remainder. Similarly, we are going to write for this step, that is 28 is equal to 18 into 1 plus 10. Here again we got a remainder. So finding the HCF is very simple using Euclid's division algorithm. Again we are going to divide this. Here we got 10 as the remainder. This remainder we are going to make it as divisor now. This becomes divisor, and the previous what was divisor, that becomes dividend here. So 18 becomes dividend and 10 becomes divisor. Now again I am going to divide. 10 ones are 10, 8 is the remainder. So again what I am going to do, this remainder becomes again divisor, and this divisor becomes again dividend. So here for this 18, again I am going to write Euclid's division lemma. 18 is equal to 10 into 1 plus 8. So this remainder I am going to take. Again this 10 becomes dividend and this remainder becomes divisor. 8 ones are 8 is 2. Again for this 10 I will be writing 10 is equal to 8 into 1 plus 2, the remainder. Again this remainder becomes divisor and this divisor becomes dividend. So 2 4s are 8 and I obviously got 0. Up to the remainder 0 will be continuously dividing, and for this 8 I am going to write 8 is equal to 2 into 4 plus 0. So now finally we got remainder as 0. then the previous divisor is nothing but the HCF. Here 2 is HCF. So for the same number 28 and 18, we did the activity and we saw that the HCF was 2. And we also did the oldest method where Euclid used by repetitive subtraction. We got 2. And this is the actual method of Euclid's division algorithm, very simple and a beautiful method. So when we continuously divide like this up to the remainder getting 0, the previous divisor is nothing but the HCF of these two numbers. So here 2 is the HCF. Likewise, using division algorithm, we can find the HCF using the action as usual, the division method. Now we are going to find the HCF for these two numbers using Euclid's division algorithm. It's very simple. As we did in the previous problem, we just take 170 as the dividend and 45 as the divisor. When we divide, 45 2s are 90 and we will be getting 27 here. Again this remainder becomes divisor and this divisor becomes dividend here, 45. And you will be writing this Euclid's division lemma, it is must. So here 117 is equal to 45 into 2 plus 27. Again this when I divide becomes 27 ones are 27 and again so this 27 ones are 27, 45 minus 27 is 18. Again I am going to take this remainder as the divisor and this divisor 27 as dividend 27. So you will be getting 18 ones are 18. Again if you subtract 27 minus 18, you will be getting 9. So again this becomes the divisor and this becomes the dividend. So 9 2s are 18. Finally we got the answer as 0. Then obviously this is the HCF. 9 is the HCF. We will be writing the division lemma. 45 is equal to 27 into 1 plus 18. 27 is equal to 18 into 1 plus 9. Again here 18 is equal to 9 into 2 plus 0. So this is the HCF. 9 is the HCF for 117 and 45. Whatever the method, I showed you through activity also. So dividing the rectangle into different squares, the same 9 will be getting, or by repetitive subtraction. Those are the old methods, but this is the Euclid's division algorithm method used to find HCF. So I hope you enjoyed to find the HCF using the Euclid's division algorithm method and the activity which I did. And the problems which are there in the NCERT textbook, it may be the verbal problems or the word problems. I'll be coming up with another video teaching you the techniques of solving any word problems. I hope it's very interesting. So I'll be teaching you the techniques, simple techniques to analyze the word problem and make it into simple equations or arithmetic things, and we can go for solving it. So I'll be coming up with that, and if you like this video, like it, share and comment. Don't forget to subscribe my channel and click the bell button for getting the notifications. I hope it was a fascinating concept and a very interesting thing to find the HCF using Euclid's division lemma. I'll be coming up with many tricks and tips for solving problems, and later on in my sessions, after completing all these chapters, I'll be coming up with NCERT exemplar problems and on the basis of competitive exams. I'll be solving all those problems. So you subscribe this channel and I hope you enjoyed. So be mathematically inclined and stay happy. Bye. Take care.